Hello students, welcome back. Today we will discuss stereochemistry of nucleophilic substitution. Okay. Till now we know that there are two types of mechanisms in nucleophilic substitution. Okay. The two types are SN1 and SN2, unimolecular nucleophilic substitution and bimolecular nucleophilic substitution. Now we are going to discuss the stereochemistry of SN1 and SN2 reactions. See, in SN1 reaction, what happens? There is racimization. Okay, and in SN2 there is inversion of configuration. We know what is configuration. Okay, in our previous class we have discussed regarding absolute configurations of optical isomers. Absolute configurations are denoted as R and S configurations. Okay. So in SN1 reaction, what happens? Racimization results. Means starting from a plus compound, we get a racemic mixture, plus minus. Okay. This is called racimization. Similarly, starting from minus, we also get plus minus mixture in SN1 process. Okay. But in SN2 process, starting from plus compound, we will get minus, and starting from minus, we will get plus. So this is called racimization. Starting from any one of the two enantiomers, we get a racemic mixture of products. But in SN2 processes, the configuration of product is always opposite to that of reactant. Okay. First, discuss this SN1 process. See, consider this substrate. Okay, this one. We will consider this compound. What is the configuration of this compound? This is priority 1, this is priority 4. Okay, this is priority 2, this is priority 3. So 1, 2, 3, rotation is clockwise, this configuration is R. Now, carbon is delta plus, bromine is delta minus. In the first step, what will happen? There is cleavage of, heterolytic cleavage of CX bond. As a result, we get a carbocation intermediate. This is the carbocation intermediate. This is the carbocation intermediate. Okay. There is ethyl group here. Okay. Isopropyl group at this position. Okay. And this is the methyl group. What is this? This is a vacant p orbital. Okay. In carbocation, we have a vacant p orbital. Now this is the plane in which the groups are placed, and this vacant p orbital lie perpendicular to that plane. Okay. Now in the second step, what will happen? There will be attack by the nucleophile. The nucleophile is suppose hydroxide ion. Hydroxide ion may attack at this lobe. Say this is part 1. Similarly, it is possible for the hydroxide ion to attack at this lobe also. This is part 2. There is equal possibility of both attacks. Attack by part 1 and part 2. Now you see, when hydroxide ion attacks by this part, by part 1, then we have this compound OH. This is carbon. Okay. This is ethyl group. This is methyl group. This is isopropyl group. So this is the product results from attack by nucleophile through part 1. Okay. But there is equal possibility of attack by part 2. Okay. By part 2, if the nucleophile attack, what will happen? We will have this compound. This is the ethyl group CH2, CHC. This is isopropyl group. This is methyl group. Now look at the configuration. Configuration of this compound is just opposite to this one. Okay, this is what? Priority 1, 2, 3. This is R compound. R. This is R. This will be S because it is mirror image of this compound. 1, 2, 3. Rotation anti-clockwise. So this is R. 1, 2, 3. Clockwise rotation. This is 1, 2, 3 anti-clockwise rotation. This is S. Now see, since there is equal possibility of attack by both the two parts, okay, there is equal amount of this compound as well as this compound in the final product mixture. As a result of that, what will happen? We will have a mixture of both the two compounds. This leads to racimization. So in SN1 reaction, always there is racimization of configuration. Okay, understood? Now come to SN2. We will consider this substrate. Say CBr. In SN2, we should consider a primary substrate. Suppose there is a methyl group here. This is hydrogen. This is suppose deuterium. Okay. Now examine the configuration. Priority 1, priority 2, priority 3. Okay. What is this? This is anti-clockwise rotation. Lowest priority is this one. So this compound is S. Suppose hydroxide ion is the nucleophile. Third one is delta plus, bromine is delta minus. Hydroxide ion will attack from the opposite side of the leaving group, bromine. Okay. This is the basic thing of SN2 mechanism. And as a result of that, initially you have a transition state like this. Okay, this is the transition state. This is methyl, this is hydrogen, this is deuterium, carbon is delta plus, bromine and hydroxide they are delta minus. What is this? This is the transition state. Okay. Now that transition state will lead to final product. What will be the final product? The final product will be this one. Now you examine. This is priority 1, priority 2, priority 3. This is the lowest priority group. Okay. So rotation is what? Clockwise. So this compound is R. Okay. So starting from an S compound, we have R compound. Okay. So starting from an S compound, we have an R compound. So this is what is the inversion of configuration. The configuration of product is just opposite to that of reactant in SN2 reaction. So remember these 2 points. In SN1 reaction, there is racimization, and in SN2 reaction, there is inversion of configuration. And this is the stereochemistry associated with what? Nucleophilic substitution reactions. Okay. Thank you.